So the next skill in Unit 3, which is quadratic functions, has to do with something called transformations of parabolas. And we've talked about how there are these two different equations, vertex form and standard form. And these two different ways of writing a quadratic function allow us to do different things. And well, one of the benefits of using vertex form is it allows us to describe how the graph is going to look. So transformations is just sort of a formal way of describing how some graphs have changed or how they're related to each other. To start with, let's review some of the information that we have when we begin looking at a vertex form quadratic. You know that we look at the a value, which is the number in front of the equation, to determine whether the parabola is going to be facing up or facing down. In particular, if it's positive, the parabola is facing up, and if it's negative, the parabola is facing down. You also know that the value of the a, if it's a big number, means that the graph is going to be stretched. And of course, stretched is the formal math way of saying what it looks like, but what it really looks like is that it's going to be narrow. And you can picture sort of the tiger that we talked about in class when we did absolute value graphs. Keep in mind that these absolute value symbols indicate that you're only looking at the number. And you're not actually going to be worried if it's negative or positive. So for example, if you have an a value of -5, you would consider that stretched, even though -5 is less than 1, the absolute value of it, 5, is greater than 1. Similarly, if the a value is a small number, and we're thinking about sort of fractions or decimals here, if you get one of these, the graph is compressed, which looks wide. Now, all of that information comes from the a value, but then there's another piece that we need in order to understand what the graph really looks like, which is the location. And the location is just determined by the vertex, which is the point h and k, where those two numbers come from the vertex form equation. So looking at the graph that we have here, if we want to compare these two parabolas, we could say that they have the same shape. They're both kind of medium wide, but they have a different location, and that's because these vertex points are different. So next I'll give you the definition of what a translation is, and this is one of the things that'll be on your Pepper quiz. Formally speaking, a translation is when you shift or stretch or flip a graph. And so if I wanted to describe how I could change this first graph into the second one, I would be describing a translation. And here's what it would sound like. We would say the parabola has shifted, and then we would just be real specific and count the units here. So I could say it's shifted 2 units right, and it's also shifted up and 1 unit up. Pay attention to the axes here. There are extra tick marks, which make it easy to calculate decimals, but this is 1 unit, and that's 2 units right there. So basically, that's all we're going to be doing for this whole lesson. But the trick is to do it when you don't necessarily see the graph in front of you, because the graph makes it easy. And the trick is to do it when you only have equations. So I'm going to show you 2 examples, and I'm going to show you 2 different methods. You should try and understand both, but once you've seen them both, you can go ahead and pick whichever method you find most helpful. Here's the first example. This is what the questions will sound like. It says, describe how f of x equals -2 times x minus 3 squared minus 4 is translated. So that's a parabola. It's translated, which means changed somehow, to get f of x equals -2 times x minus 6 squared minus 5. So the first thing I notice is that both of these parabolas have the same a value. And this a value is telling me that it's going to be facing down. And the 2 is a big number, so I can imagine that these are going to be kind of narrow graphs. The first method you're going to use in order to create your description is going to be to sketch the graph. And so I'm going to just draw a set of axes here. And this graph doesn't have to be perfect. You just want to approximate it, which will make your description easier. So the other thing that I noticed about the first parabola is that the vertex is going to be at +3, -4. Notice that I changed the h value. if I want to graph that, I'm just going to kind of roughly make some tick marks here, over 3, and then down 4. Here's my first vertex, and my parabola faces down, and it's kind of skinny, so it looks something like this. And again, that's not perfect, but it's close enough for creating a description. I'm also going to go ahead and just label this that this is the first parabola so I don't get confused, especially if you don't have color coding, which I can do. The second parabola has a vertex at positive 6, negative 5. And so if I go to graph that on the same set of axes, I would go over another 3 units, and then I would go down to negative 5, so that it's going to be right here. And again, I'm going to draw sort of a narrow parabola, and just in case I forget later, this is the second parabola. So the instruction said to describe. Basically, I'm going to do exactly what we did above. Starting at the first parabola, if I wanted to get to the second one, first I would have to move right, and I would move right 3 units, which I can count up top. And then I would move down, and I would move down 1 unit. So the answer to this translation question is real simple. The parabola has shifted 3 units right, and down 1 unit. And that would be the answer. If the A value was different, we could also say that it had been flipped or compressed, but in this case, since they're the same, there hasn't been any change in the direction or the width of the parabolas. Now, for those of you who've been paying attention, you notice that, in fact, this whole translation skill really only depends on the vertex. So here's a second method, which for some people may seem quicker, but you do have to be a little careful. Example B is pretty similar. Again, it gives us 2 different parabolas. They're both in vertex form. And I want to describe how the first parabola is translated to get the second one. This method depends only on the vertex. So I'm going to write down the vertexes of the 2 equations right next to each other. The first vertex is negative 6, negative 1. And the second vertex is positive 1, positive 3. And I'm just going to remind myself that these first numbers are the x values, which means that when they change, they're going to control the parabola's right or left placement. So moving from the first parabola to the second, numerically, I'm adding 7, which means the graph is going to shift 7 units to the right. And the temptation will be to get that confused with moving up. It's not moving up because the x controls right or left. On the other side, y does control up or down. And in this case, going from negative 1 to positive 3 is the same thing as adding 4, which now means that my graph has also shifted 4 units up. And to make this into a sentence here, I'm just going to squeeze some extra words in. And we'll say the parabola shifts 7 units to the right and shifts 4 units up. And that would be your answer. You should pause here in your video and turn the page to complete the answers on the next page. After you restart the video, I will be showing you the answers. If you need to replay either of these examples to get more clarity, I recommend doing so.